The night sky is currently undergoing significant transformations that will dramatically alter its appearance in the coming years, possibly sooner than expected. What we once considered stable and constant is now entering a period of dynamic change. These changes are not merely superficial but have the potential to reshape our understanding and measurement of the universe. Leading scientists and astronomers worldwide are raising alarms about an impending shift in our cosmic understanding. Notably, renowned astrophysicist Neil deGRASSE Tyson has drawn attention to one such change. The North Star Polaris is set to undergo a dramatic transformation. The story behind this celestial event is not only fascinating but also deeply unsettling. Polaris, a star that has served as a fixed point in the night sky for centuries, is on the verge of losing its stability. For ages, Polaris has been an essential reference point for astronomers, navigators, and cosmologists, guiding people both literally and symbolically. But now, this once reliable guide is nearing a major transformation that could alter how we perceive the night sky and the astronomical calculations we have long taken for granted. This change carries significant implications, both scientifically and culturally. To fully understand the weight of the situation, we must first explore the history of Polaris, a star believed to be entering the final stages of its life. For millennia, Polaris has been regarded as the guiding star, a cosmic beacon that has helped both astronomers and sailors navigate the vast oceans. Revered by civilizations since ancient times, Polaris has held a unique place in the heavens, symbolizing steadiness and reliability. Its constant presence has been a cornerstone of celestial navigation, providing a steady point of reference in the otherwise changing sky. However, recent developments suggest that this era of stability could be drawing to a close. A major report presented by the esteemed Royal Astronomical Society in September 2023 highlighted the future of Polaris, indicating that the star is nearing a catastrophic event, a burst that could permanently remove it from the night sky. This revelation is astonishing, as it signifies the loss of a star that has been pivotal to both scientific exploration and cultural traditions. Before delving into the potential consequences of this event, it is essential to understand Polaris itself and the forces driving this dramatic change. Polaris, also known as the North Star, occupies a unique and significant position in the night sky. Its location is directly tied to its proximity to the celestial North Pole, meaning it appears directly above the Earth's northern pole. This gives the illusion that the star remains fixed in the northern sky while the other stars seem to rotate around it. This seemingly static position has made Polaris a vital tool for navigation, particularly for ancient sailors who relied on its guidance to traverse the oceans. Polaris is part of the Ursa Minor constellation and stands out not only because of its location but also because of its moderate brightness. However, Polaris is much more than a simple bright spot in the sky. It is a yellow-white supergiant star, significantly larger than our Sun, and part of a complex stellar system. This system includes 3 stars: Polaris AA, Polaris OB, and Polaris B. To the naked eye, Polaris appears as a single star, but it is actually a binary system with a third star orbiting the primary pair. The gravitational interactions between these stars shape their orbits and, in turn, affect their luminosity and other key characteristics. Any disturbance in this delicate balance can lead to erratic changes in brightness, pulsation patterns, and other observable features. Despite advancements in astronomy, scientists still do not fully understand the intricate cycles that govern these celestial interactions, leaving much of Polaris' future behavior shrouded in mystery. Polaris is located about 323 light-years from Earth, meaning the light we currently see from the star was emitted over 300 years ago. This vast distance has important implications for how we observe celestial events. If Polaris were to explode today, we would not witness the explosion for another 323 years due to the time it takes for the light to travel to us. This time delay means the explosion may have already occurred, and we are simply waiting for the light from that distant event to reach us. Astronomers have based their projections on the evidence currently available, which strongly suggests that Polaris is approaching the final stages of its stellar life cycle. However, due to the immense distances involved, the effects of this change have yet to reach us. This highlights the challenge of studying celestial bodies at such vast distances. When we observe significant changes, they may have occurred centuries earlier. Nevertheless, these projections provide crucial insights into the potential future of one of the most iconic stars in our sky. The significance of Polaris throughout human history cannot be overstated. From ancient civilizations to the present day, the North Star has played a pivotal role in navigation and cultural symbolism. Its stability and near-fixed position near the celestial North Pole have made it an essential tool for explorers and adventurers, particularly those in the Northern Hemisphere. Ancient sailors, for example, relied on Polaris to navigate vast oceans, using its constant presence to determine their direction. Even in today's technologically advanced age, the star remains a critical reference point in astronomy and navigation. Beyond its practical use, Polaris holds deep symbolic meaning in various cultures. In some traditions, the North Star represents constancy, survival, and immortality. It has been seen as a guiding light, both literally and figuratively, in the vast and ever-changing fabric of the night sky. Unlike other stars that rise and set throughout the night, Polaris has remained a steady presence, making it a symbol of reliability in an unpredictable world. However, recent observations have raised concerns about the future of this celestial symbol, as its behavior is no longer as predictable as it once was. In recent years, Polaris has begun to exhibit behaviors that deviate from what astronomers have traditionally expected. This unsettling change in its pulsation cycle has puzzled scientists, who are now conducting further research to understand the causes behind these inconsistencies. Typically, stars like Polaris follow a regular pattern of pulsations, periods of brightening and dimming that occur at predictable intervals. Yet, Polaris has recently entered a more erratic cycle, showing unexpected variations in its brightness. This has raised alarms in the astronomical community, prompting further investigation into the star's behavior and stars, especially those nearing the end of their lives, often serve as indicators of their impending demise. The irregular behavior observed in stars like Polaris is consistent with what researchers have witnessed in other stars approaching their final stages. Polaris, once known for its regular pulsations, is now displaying signs of instability. The growing length of its pulsation cycles, which were once stable, suggests that the interactions within the Polaris system are becoming more chaotic. Though these changes may seem small, such as a 4.5% increase in the duration of its pulsation cycles, they are significant to astronomers, as they can provide valuable insights into the underlying processes driving the star toward its eventual death. Some astronomers suggest that the gravitational forces between stars in the Polaris system could be responsible for these fluctuations, potentially affecting the star's atmospheric conditions and, in turn, its pulsation patterns. However, not all scientists agree with this explanation. A growing number of researchers believe that Polaris is on the brink of a supernova, a massive stellar explosion that would mark the end of its life. This hypothesis is supported by the fact that Polaris is displaying behavior similar to Betelgeuse, a prominent star in the Orion constellation, which has shown dramatic brightness fluctuations, leading to widespread speculation that it might explode in the near future. Betelgeuse's behavior has attracted significant attention, with some experts warning that its imminent end could be approaching. Polaris' recent behavior mirrors that of Betelgeuse, suggesting it might also be nearing its explosive conclusion. NASA has shown great interest in Betelgeuse's irregularities, particularly its potential for a supernova, which could result in a breathtaking celestial event visible from Earth. While NASA has not expressed the same level of concern about Polaris, the unexpected behavior of both stars has prompted astronomers to keep a close watch on them. The possible supernova of Betelgeuse has been closely monitored, as such an event would offer valuable insights into the life cycles of massive stars. Though Polaris' unpredictable behavior has raised concerns, no official announcement has been made by NASA regarding increased monitoring of the star. Still, astronomers remain cautious, as both Polaris and Betelgeuse are in the final stages of their life cycles, making them prime candidates for further study. Stars undergo a complex evolutionary journey through various stages. When stars are newly formed, they are typically dim and cool. As they age, they enter the main sequence stage, during which nuclear fusion occurs in their cores, a phase characterized by stability. Stars can remain in this stage for billions of years. Eventually, when a star's hydrogen fuel is exhausted, it begins to expand and becomes a red giant. During this phase, the star's temperature and brightness increase dramatically. Eventually, the star reaches a critical point where it can no longer maintain its structure, leading to a catastrophic supernova. If Polaris were to undergo such an explosion, it would be visible from Earth and would be an awe-inspiring sight. The star would become incredibly bright, surpassing the brightness of the Moon and becoming one of the most noticeable objects in the night sky. This spectacular display could last for weeks or even months before gradually fading. The explosion would also temporarily disrupt our perception of star groupings, as Polaris is part of the Ursa Major constellation, and the brightness of the supernova would overshadow nearby stars. Despite the potential for such a striking light show, there is no danger to Earth. Polaris is situated about 323 light-years away, meaning that even if a supernova were to occur, the energy would dissipate long before it reached our planet. The event would primarily be a visual spectacle rather than a hazardous one. In comparison to Betelgeuse, which is expected to explode in the near future, Polaris supernova may not be as visually dramatic. However, it would still be visible to the naked eye and likely outshine many surrounding stars. Such an event would provide an exciting opportunity for both amateur stargazers and professional astronomers to observe a stellar explosion in real time, offering valuable data for understanding stellar life cycles. As the scientific community continues to grapple with the implications of Polaris' potential supernova, researchers are also exploring the broader effects of such an event on our understanding of cosmic evolution and galactic phenomena. The study of supernovae, including those from massive stars like Polaris, offers critical insights into the life cycles of stars and the dynamics of galaxies. One key area of interest is the role that supernovae play in the distribution of elements throughout the universe. When a star like Polaris explodes, it releases a vast array of elements into space, including those heavier than iron, which are essential for the formation of planets and life. This process contributes to the evolution of the interstellar medium and affects the chemical composition of future generations of stars and planetary systems. Understanding these mechanisms helps astronomers trace the origins of elements in the universe and the conditions that led to the formation of our solar system. Additionally, the study of supernovae provides insights into the potential for such events to trigger the formation of new stars. The shock waves from a supernova can compress nearby gas clouds, initiating the process of star formation. This feedback mechanism is a crucial part of cosmic evolution, explaining the observed distribution of stars and star clusters within galaxies. The light from a supernova, like one from Polaris, also serves as a natural laboratory for testing physical theories under extreme conditions. The enormous energy released during the explosion allows scientists to study the behavior of matter and radiation in environments that cannot be replicated on Earth. This includes exploring the properties of neutrinos, understanding the formation of neutron stars or black holes, and testing the limits of our knowledge of nuclear physics and general relativity. In addition to its scientific significance, the potential explosion of Polaris has captured the public's imagination and sparked renewed interest in astronomy. Outreach programs and educational initiatives are using the possibility of such a dramatic celestial event to engage the public and inspire the next generation of scientists and explorers. These efforts aim to make complex astronomical concepts accessible and exciting, helping foster a deeper appreciation for the universe and our place within it. Ultimately, while the possibility of Polaris undergoing a supernova is a fascinating and rare event, it highlights the dynamic and ever-changing nature of the universe. The study of such phenomena reminds us of the vast time scales and intricate processes that govern the cosmos. It serves as a humbling reminder of the grandeur and complexity of the universe, encouraging us to continue exploring and expanding our understanding of the universe in all its forms.